Yeah. I think starting to fill out here. So let's get started. Hang on a second. There we go. For the folks who weren't here last week, I'm Nate Atkinson. I'm one of the engineers on the DevOps team here at GDT. And this week we're going to talk about data security. Go kind of a high-level overview of some of the technologies at use and some of the principles at play. So some of the sort of basic concepts behind data security. There's a concept of privacy, all right? You want your data to be private. You don't want other people to be able to read your data. There's the concept of authentication. If someone sends you some data, you want to be able to verify that the data that you received is actually the data that someone else sent. That's integrity. Integrity and authentication, similar idea. Integrity, the data that you get is what the other person sent. Authentication is that you can verify the identity of the person who sent you data. Sort of basic concepts, what we're aiming for with data security. When we talk about data security, we're talking about two different kinds of data doing two different things. So there's data at rest. This is data that's sitting on a hard drive somewhere, on a computer or on a tape drive, I guess. Data that's stored. And we also talk about data in transit, which is data that has been sent from one computer and is in transit to another one. Data that's in a wire somewhere, or passing through a buffer and a router. Well, we're first going to talk about data at rest. So a couple of ways that we can protect data at rest is through hardware encryption of the data, letting our operating system do the encryption for us, and application and user-initiated encryption. So some of the tools for hardware encryption, we've got self-encrypting drives. Basically, you order from Hitachi or Seagate or your hard drive vendor a self-encrypting drive. When you set up that computer hard drive, you can actually set a password on it, and all of the data is then written in encrypted form and can only be accessed by entering the password when you boot up the computer. You can also get encrypting enclosures. This, you take your hard drive, you stick it in the enclosure, and the enclosure either has a little key type device like that, or maybe it accepts a passcode. And you can use this for your external drives. There are even some a little bit hard to find for internal drives. Some of the benefits of this kind of technology is that it's implemented in the hardware. So you don't need to install any programs on your computer to make it work. It's implemented right there at the hardware layer. You can run any operating system you want. If you're, want to still be on Windows XP, you can use a self-encrypting drive and still have secure data at rest. The encrypting enclosures, I think, are kind of cool with the external key. They're a little bit hard to find, but if you were, for example, passing through customs at an airport, and it's, say, a country that's known for industrial espionage, you have your data here on your drive, and then you send your key via some other route. You give it to your business associate. You mail it ahead of time, so that while you're actually traveling with your data, that you can't access it. So if someone at the customs desk says, "What's on your hard drive?" you can't show them. That's kind of cool. The self-encrypting drives, they're useful. You hear news stories about someone left a laptop on a train and it had millions of social security numbers on it or sensitive company information on it. A self-encrypting hard drive will help to protect your data in that case. They can get the device, but without the password for the hard drive, they're not going to be able to get the data off of it. Some of the disadvantages are these are kind of black boxes. You just kind of have to trust that the company that made them did it correctly without vulnerabilities. But they're kind of convenient. So if you don't want to bother with hardware encryption, you can let your operating system handle it for you. One of the methods is file system encryption. Windows has supported this for quite a while. You can make encrypted drives or encrypted folders. But that may or may not encrypt the metadata. And when I'm talking about metadata here, one of the key things is like file names. So you might have encrypted super secret file 123, but if someone gets a hold of your hard drive, they can see that you have super secret file 123, but they're not able to decode it, but they still know that you have it. Depending on the operating system and file system that you're running, some will encrypt the file names and some won't. Moving kind of a layer down from that in the technical stack, there's the concept of block layer encryption. If you use Windows, this is something like BitLocker. TrueCrypt, which is no longer around, does the same thing. A few different options on Linux and Unix servers to do this as well. And this is usually a pretty secure option and what most people go for. And numerous solutions for this. And then we can also talk about sort of application and file encryption tools. So this is your software application has a tool for securing data built into it. This might be password protecting a document in Word or PDF or a password protected zip file. The quality of the encryption on these will vary by the application. Some it's enough to keep out the casual looker, but not someone who's really serious about getting to your data. Others are quite good. And then you can also use generic sort of encryption tools that take any kind of content and will produce an encrypted version that only people with the password can read. Really common tool for this is PGP, or also called GPG. Two different implementations of the same thing. A few other encryption tools of, again, varying quality. An additional thing to talk about with application and file encryption is if you're running a server, for example, say a database server, and the database software itself supports encrypting the data. What this means is if someone gains access to the server, say even admin access, they can see that data is there on the disk, but that data is still protected even against someone with admin access to the machine, which is pretty cool. All right, so we talked about data at rest for a little while. Now we're going to talk about data in transit, and kind of two areas where you can protect this data. One is through your network infrastructure, and other way is through your operating system, utilities, and various applications. So one thing that's important if you want to secure your data in transit, you should actually secure your infrastructure. Don't let people come up and put random things on your network. You can use tools for managing your network ports to make sure that nobody puts rogue devices on it. Secure it so that no one can put a packet sniffer in a network line. And then there are multiple products that can be broadly termed as secure gateways. So this might be a router that implements VPN. This might be a router that implements MACsec. Or sort of specialized devices that will, for example, sit on one end of a network cable and another device on the other end. They take the data, they transparently scramble it, and only the corresponding box on the other end is able to unscramble it. That's a little bit of an esoteric product, but using tools like secure VPN networks allow you to essentially create a virtual network cable from one branch office to another branch office, and the traffic that passes over that cable is secure. People can't mess with it or read it. This is useful if you if you have multiple offices and multiple sites, especially if, and the encryption is especially useful if you were to have a remote office in, say, a country that's known for industrial espionage. In addition, there are applications and tools in your operating system for providing secure data in transit. So we can have site-to-site VPN, but you can also install a VPN client on your client machine that allows you to access a corporate network remotely. So if you're sitting in the coffee shop, not only does your VPN client allow you to access your network at work, but it also encrypts the traffic between you and work so that other people can't read it by sniffing the network. There is a sort of a generic technology that when it came out, it was called SSL. People still call it SSL. It's also called TLS, stands for Secure Socket Layer or Transport Layer Security. Basically, this is a tool that software engineers can use to take a normal network connection that's sending plain text over the wire and put a package around it, wrap it in an opaque container so that no one can see the data that's going through that network connection. It works using some mathematic stuff called public and private key cryptography. Basically, what this means is that when you connect to say a web server over HTTPS, which uses secure socket layer, the web server, it has two keys on it. It has one key that it's going to give to you, and it has another key that it keeps. The key that it keeps can lock the data, and that data can only be unlocked with the key that it gave to you. Then you can send data back, locking it with the key the server provided, and it can only be unlocked by the corresponding key on the server. It's a really powerful technology that's useful for securing these connections. It's commonly used for web browsing. So if you look in your address bar in the browser, used to be pretty much most sites you would see HTTP www. whatever. And now they're moving over to most sites have moved to HTTPS by default, which is the secure HTTP. It's wrapped in SSL. And that'll mean you get usually a green lockbox in the address bar and maybe a green address bar depending on how they've implemented it. And that means that nobody can eavesdrop on your communications with that web server. No one can even see which pages on the web server you're visiting, which is really nice. In addition, it protects that data from tampering in transit. So Comcast, for example, has software that if you are on an unsecured HTTP connection, can actually alter the page that your browser retrieves. The web server sends one page, Comcast intercepts it, alters it to add some of their code to it before sending it to you. That's possible with unsecure HTTP. It's not possible with HTTPS. The unsecure code that they send, I think it's an update notifier for your modem. So you're browsing, random website, and hey, you get a pop-up from Comcast saying you should upgrade your modem. How useful. So commonly used for web browsing. That's where most of that happens. In addition, the developers of applications or users can choose to encrypt messages. So using PGP or GPG, this is an email that I think my wife sent me when we were dating, and she chose to encrypt it. And I have no idea what it says now. If I were able to track down my old keyring, I could probably decrypt this, but no one knows what this says. So you can use tools like PGP to encrypt your data that you send, emails usually or file attachments, or maybe the application that you use does end-to-end encryption. And in that way, you can make sure that no one's reading your love letters. no one's sending you data that's purports to be from one source, but is actually for another, and no one is manipulating your data in transit. So that's sort of a high-level overview of data at rest and data in transit. And I breezed through that really quickly. Are there any questions or anything people would like to discuss? Yes?
The hard drives, do most of the systems that we have now are already, the hard drives come encrypted?
It depends. Usually not. Some of the newer solid state drives, they've started adding that as it's becoming more common on solid state drives. What they'll actually do is by default encrypt everything but have a blank password, and then you can set a password if you want, and that way your data is secure, but it's less common than I think it should be. So if you want a self-encrypting drive, you kind of have to look for it. I don't know what our in-house IT does, so couldn't tell you. One of the things that I should have discussed but didn't. How many of you guys have seen you're browsing a web page, maybe it's an internal website, and you get that pop-up message that says, this connection might not be secure, there's a certificate mismatch. You guys have seen that? Okay, so one of the things that Secure Socket Layer does is, in addition to, so you've got these two keys, the server's key and the key that the server gives out, the public key and the private key. Those keys are actually signed by third parties, usually. So the server says, I am google.com, here's my public key, and the guys over at VeriSign have confirmed, they've put a little stamp on that key saying, yes, we affirm that this is Google's key. And using some cool cryptography tools, they've done that in such a way that it can't be tampered with. So your web browser gets this key, looks at the stamp, yes, this is google.com. Am I actually talking to google.com? Yes, I am. Everything's good. When setting up internal websites at our company, a lot of companies will do this. Instead of getting that third party to sign that key, they will say, yes, I confirm that this is the site, but I don't have any certificate authority. I don't have a stamp on the key. And when you get that pop-up warning in your browser, it's basically saying, hey, this key is missing the stamp, or the stamp on the key doesn't match the address of the server. This is a good warning if someone is actually messing with your network connection. You would see this kind of warning. Pops up more often though, because people just haven't got that stamp on their key to verify that it's actually a genuine one. So, all right. So high-level overview of a little bit of the data security space. Thank you.